There we go. Can anybody see perhaps a bit of a problem we're running to at this point? What do we think? What's happening with our lines? Brilliant. They are exactly parallel. Now, isn't it funny that we spent time in the last unit talking about parallel lines, and now, look, it's important that we know what parallel lines are. And as soon as we can identify our lines as being parallel, we know that they're never going to intersect. So, there we go. This is the second scenario we're going to run into when we plot these types of equations. So the graphs do not intersect. We can write, they don't. How many solutions are there? Well, there are 0 solutions. Because those lines are parallel, they will never intersect. So the easiest way to identify when this is going to happen is to look at the slope. If the slopes of my lines are the same, then I am going to possibly have 0 solutions. Can anyone maybe jump to the next possible scenario? We've had lines that intersect, so they have 1 solution. We have lines that are parallel, which will have 0 solutions. Is there anyone that can maybe think of the third scenario? And I'm going to give you a hint. It has nothing to do with perpendicular lines, because perpendicular lines will intersect at a 90-degree angle, but there's only 1 solution. Kaylee, you're on the right track with 2 solutions, but it's more than that. How could we have straight lines that crossed each other more than once? Like, can you think of how that would maybe work out? What are we going to run into there? I have a feeling some of you are on to me, but possibly not. Let's perhaps look at an example. On the same coordinates, I'm thinking you got it. Let's look at the third example here. I'm going to do the same process again. Slope-intercept form, plot the lines, see what happens. So I'm going to move the 2x to the other side. And I'm going to end up with y is equal to negative 2x minus 1. Okay, so I know my y-intercept's minus 1. My slope is negative 2 over 1. So I'm going to go down 2 over 1. And then I have a line. 2 points, going to connect those points. Now I'm going to do the same thing with the other one. I'm going to subtract 4x from both sides, and I'm going to end up with 2y is equal to 4x negative minus 2. Divide everything by 2. End up with y is negative 2x minus 1. So plot my y-intercept, minus 1, and use my slope, negative 2 over 1. What just happened? I just changed my line from blue to green. What do you notice is going on here in terms of my equations? So we had the idea that maybe there was going to be 2 solutions, but we had straight lines, so straight lines can only cross each other once, ever. Or they can cross each other 0 times if they're completely parallel. But what would you say is happening here when my lines are literally on top of one another? What do we think in terms of solutions for these guys? How do we kind of quantify how many solutions there are? If I asked you how many solutions, they cross everywhere. So no matter where I look on that line, I have a solution. They're literally the same line. They lie on top of one another. So if I looked at this point, I would end up with a solution like right there. I'd have a solution here, I'd have a solution here, I'd have a solution here. Literally everywhere I have solutions. So where do the graphs intersect? Everywhere. And Abby's hit the nail on the head. There are exactly infinite solutions. No matter where you look, those lines are on top of one another. It's a solution. I could check on this kind of little graph I have in front of me. I could go out to, a million and check there. I could go out to a trillion and they'd still be on top of one another. So it's still a solution. So because the slopes are the same and the y-intercepts are the same, we call these coincident lines. It's a fancy math word. And I don't think that it even matters if you know coincident or not. The important thing here is that the lines are on top of one another. You're going to have infinite solutions. Literally everywhere you have a solution. So I mentioned at the beginning of the lesson that there was going to be 3 scenarios we'd run into. We've seen all 3 scenarios now. So let's put them in a little chart. And we will kind of maybe just summarize them. So slopes of the lines, the second we have different slopes, we're going to have exactly one solution. So if we drew a little graph here, I'm going to draw a little graph for each of these. If I have a line here, and then I have another line down here, I have one solution. So I end up with one intersection and one solution. Do I have a solution at 3, -13? I don't think my graph goes to -13. So, yeah, I only go up to 6 there, Alex. So you'd have to actually plug it in and see if it satisfied both equations. If I have lines with the same slope, something there, I would have, we can call it 0 solutions. 0 intersections, 0 solutions. The last one here is coincident lines, where I have lines that are exactly on top of one another. Difficult to draw. And I end up with infinite solutions and infinite intersection points. So those are the 3 things. If we have 2 lines, those are the only 3 scenarios we can end up with. And the whole rest of chapter 7, or unit 7 I should say, we're going to try to figure out if we have parallel lines, if we have lines with different slopes and different y-intercepts or intersect at one point, or if we in fact have the same line or a coincident line that's on top of another line. So that's all we're doing for this whole unit. We're just going to look at different ways to figure that out. It's 10:05. We have about 15 minutes left. I'm going to maybe go through a couple more of these questions. But if you had anything from the previous unit that was like extremely pressing that you wanted to go through before you submitted your learning guide or wrote that test, You could throw that into chat. If nobody has any extremely pressing questions, then I will do a few more examples of this stuff that kind of look like some of the ones that you're going to see in the learning guide. I think I have 3 examples left. You have an extremely pressing question. Fire it in there, Alex. Page 7, number 4 and 6. Okay. Well, Alex, I've already done both of those questions. Graph the line. So we did. How did we do it? We converted it into... We didn't convert it. We found, because it was in slope point form, we already knew the slope was this guy, the m. So 3 over 5. The point was this 4 and the 5. And remember, when we find the point, you need to flip the signs. So if it says x plus 4, because the general slope point form looks like y minus y1 is equal to m, x minus x1, your equation needs to be in that same form. So if I get y minus something and m x minus something, what is that something going to be? So I guess that was maybe the trickiest part of doing this, is determining what that point was. So in this case, the minus 5 was here, so I put in a plus 5. And over here I had a plus 4, so I needed to put in a minus 4 to end up with the right sign. So my point was negative 4, positive 5. I have the slope, and I can go from there. So that's the tricky part of slope point form, is figuring out what that point is, because we have to watch our signs. Think of what the general form looks like. I did this over here as well, and then go from there. Number 6, I think I did almost all of these. Convert the following to general form. Remember, we have to have ax plus by plus c equals 0. A must be a whole number, so it has to be a positive integer. B and c can be whatever you want, as long as they're not fractions. So just to make sure I've done all of these questions for you guys, let's start with this one, and let's get rid of our fraction. So I'll jump way up here. Y is equal to 5 over 3x plus 3. I want to get rid of my fraction. I'm going to multiply everything by 3, because my 3 is on my denominator. 3 times 5 over 3 is going to give me 5, and 3 times 3 is 9. So 5x plus 9. I'm going to move the y to the other side to end up with 0. So I get 0 is 5x minus 3y plus 9. There you have a splendid. Nobody else threw in any questions, so I'm going to assume that that's it. No problem, man. All right, I want to jump back, kind of hopping all around here today. I'm going to maybe look at a few of these examples, have about 10 minutes, and we're just going to solve them. And the question is a bit kind of misleading, perhaps. It asks, determine the number of solutions. So the question isn't asking us what the solution is, it's asking how many solutions there are. So we have 3 choices. We have 1 solution, we have 0 solutions, or we have infinite solutions. That's what your answer is going to be. 1, none, or infinite. That's it. Those are the 3 choices. So we need to look at our lines and compare them. The easiest way to do that is maybe put them into slope-intercept form, because once I've done that, I can figure out if the slopes are the same and the y-intercepts are the same, they're the same line. If the slopes are the same but the y-intercepts are different, then I have 0 solutions because they're parallel. And if the slopes slopes are different, automatically my slopes are different, I'm going to have one solution. So let's convert these puppies. I have line number 1, I'll call it. I have line number 2. I'm going to switch them into slope-intercept form. So number 1, x plus y is negative 2. I'm going to subtract x from both sides. Negative x minus 2. My second line, negative 2x, negative 2y is 4. I'm going to move my y to the other side to make it positive on the other side. So I'm going to add 2y to both sides. Then I'm going to move the 4 over after. So I have negative 2x is equal to 2y plus 4. Subtract 4 from both sides. Negative 2x minus 4 is 2y. And then divide everything by 2. Show that step. So I get negative x, or negative 1x, minus 2 is equal to y. All right, so I'm going to compare my equations here. This was line 1. Y is negative x minus 2. Here I have the same thing. So our slopes are the same. If I look at the slope of my first line, it's equal to the slope of my second line. My y-intercepts are the same. Slope of my first line is equal. The y-intercepts are the same. So I can just write something like, these are the same line. The slopes are the same, the y-intercepts are the same. We can call them coincident lines and infinite solutions. So that's all the question was asking. Do we have 1, 0, or infinite solutions? In this case, we have infinite many solutions. Let's look at the next example here. I'm going to convert both of these into slope-intercept form as well. So 4x plus 6y is negative 10. Move the x to the other side. 6y minus 4 equals negative 4x minus 10. Y is equal to negative 4 over 6x minus 10 over 6. I should probably simplify my fractions. Negative 2 over 3x and then 10 over 6 can be simplified to 5 over 3. So that's the first one. My second line, negative 2x minus y is negative 1. Going to add y to both sides. Plus y minus 1, add 1 to both sides. Negative 2x plus 1 is y. So I look at the slopes now. I see this slope is negative 2 over 3, and this slope is negative 2 over 1. So I can just write the slope of my first line does not equal the slope of my second line. So what does that mean? I have two lines with different slopes. It doesn't even matter what the slopes are. As soon as I have two lines with different slopes, I have only one solution. Now, we just kind of look at what's been happening. The first example, our lines were the same. The second example, our lines were different, so we had one solution. The third scenario is that our lines are parallel, and you can probably guess that this last example is going to give us parallel lines, but we're going to do it anyways because we can use the practice. So 3x plus y, negative 1, I get y is negative 3x minus 1. Second one, negative 6x minus 2y is 12. I'm going to move the 2y to the other side. I'm going to subtract 12 from both sides. And I'm going to divide everything by 2. So I can see that my slopes are the same, but my y-intercepts are not. So I could say B1 does not equal B2. What can I gather here? My slopes are the same, meaning my lines are parallel. I can't say that these are the same line because my y-intercepts are different. If the y-intercepts were the same, then I'd have coincident lines. But because my y-intercepts are different, I don't have coincident lines. I have parallel lines and 0 solutions. So that's it. In terms of the learning guide, I had a quick look earlier. The first 3 pages, so solve by graphing, you guys can do that. This same thing, we're going to plot these on the graphs. Linear system, so just getting the definitions on the 3rd page, and then determining the number of solutions like we just did on question 10. So you're good to go up to the end of page 3 on the learning guide. A couple things I'd like to remind you of before we get going here. If you would like to come to archery tomorrow, we're at same place on Enterprise. The address, or sorry, it's technically Cooper, 1771 Cooper, but we find it off Enterprise is a bit easier. Hardcore Archery. Be there tomorrow at about 10:45. We'll have an hour and a bit of archery. If you didn't come last week, you can come this week. It's fine. If you did come last week, you're good to go, and you can just shoot as soon as we get there. So we're going to get tons and tons of shots in tomorrow. And I'm sure Mrs. Wood and Ward have warned you, and you guys have likely not forgotten about it. But Monday, you're not going to have math. You guys are at Central doing your English midterm exam. So I understand it's an essay, and that's about all I know about it. But 9 o'clock, Central Gym. And hopefully we'll see you guys both tomorrow at archery. And then on Monday at Central, we have 2 sections left in this unit, lesson 2, lesson 3. And then we'll have a review day on Thursday. And then you guys have the entire break to get the Unit 7 test done. So I'm going to leave it there for today. Thanks very much for those of you who submitted your learning guides from Unit 6. I apologize for not getting them back to you sooner. I will get that done today prior to lunch. And I'm sure we'll see a lot of you guys tomorrow at archery. So have a good weekend if I don't see you. Bye-bye.